And we're live. Hi, everyone. Welcome to On.NET Live. This is where we talk about all the great things that happen within the .NET development community. Today, we're going to have a special episode where we're going to talk about different messaging patterns that you could start using in your applications today. And I have my friend Clemens here who's going to talk to us about it.
So, yes, hello.
How are you doing?
I'm doing great. And thank you for, I think on this show I've not been, but we've been on shows together.
We have. We've done some pre-recorded shows before, but you have not done a live one today. So
I have not. I have done live talks in front of people, but not in front of probably so many people.
Yeah. So this is going to be a little bit different. Yeah, this will be a little bit different. We'll have some folks that are in our live chat. We'll have folks that are coming from Microsoft Learn, from YouTube, from Twitch, and we usually get a crowd from all over the world, man. We have a lot of folks that tune in from Africa and from India, from Australia, and like just different parts of the world. So we really love like this opportunity to be able to share like some great content with you.
Yep.
So Clemens, you want to tell folks who you are a little bit? Like what do you do, just for folks that don't know?
Yeah, I'm the architect for the messaging services in Azure. So those are EventGrid, ServiceBus, Event Hubs, and the Relay. They're also the foundation for many other services. Logic Apps builds heavily on ServiceBus. IoT Hub builds heavily on Event Hubs. We've also started things like notification hubs. And so we're kind of the team. Our team is the one that's driving all those, the core messaging services. And we're also engaged in standardization. So I'm myself the chair of the ANKP technical committee in OASIS, where we do that international standard, and I'm also in the Cloud Native Foundation for the Cloud Events project, where I'm sort of acting as the architect, even though that role doesn't formally exist, but that's kind of how it plays out.
Nice. It sounds like you're involved in a lot of great stuff. But before we really start diving into like the messaging conversation, I do have some links that I'd love to share with folks. So let's switch over to that really quickly, and then we could talk about like messaging some more. Now, the first link that I want to share with everyone. So if you don't know, this is Microservice March here on .NET Live TV. And so one of the links I want to share with you is our .NET architecture guides. And the way that you actually get to this is if you go to the .NET website, which is .NET, and you come to the Learning Center and Architectural Guides, you see we have a whole collection of ebooks that are available for you to read for free. You could download a PDF file if you want to, or you could read it in your web browser. But here you see we have topics on architecting cloud native apps and Blazor and gRPC and even an ebook for Dapper, which just came out in V1 maybe just like a couple of weeks ago. So if this is something that you're interested in, something that you want to take a look at, I definitely recommend you head over there. Also happening at the end of this month on March 26th is Let's Learn.NET. And again, since it's Microservice March, we're going to do a microservice edition of that. So this is going to be happening on March 26th. And if you head over to this website, you see the agenda is already all there. So we're going to talk about what are microservices, why are they important? There's going to be some live Q&A, and then there's going to be some workshops too. So you'll be able to see like some hands-on demos about how things actually work and plug together. So definitely recommend you RSVP for that and check it out. And the last thing that I wanted to share with folks, and this kind of ties in a little bit with what we're going to talk about today. This is a doc that lives on the Azure messaging documentation site. And it's about how do I choose the right messaging service? And we're going to see a couple of those when we really dive into some of the demos that Clemens has. But, it's a very common question, right? Like, how do I choose the thing? Should I use EventGrid or Event Hubs or ServiceBus, or should I use, what's that thing that we have called? Storage queues or something like that. Like, what's the thing that I'm supposed to use? So this is a really good document that helps us kind of understand the differences between those things and the nuances and help us make the right decision. So I'll go ahead and share these in the chat so folks could take a look at them. And then now I'll switch back over to Clemens, and then we could start talking about like our main topic. Sounds good?
Great.
Let's do it. So one of the things I wanted to start off with, Clemens, is, I really like messaging and just like the idea of messaging, because I feel like it's a topic that's I don't have to be building microservices to make use of. I don't have to be living in the cloud to make use of it. What I mean? I don't have to, have some super hyperscale scenario. It's something that regardless of whether I have what people, I guess, call a monolith or, a bunch of distributed services, messaging could really play a really vital role in how, things happen and how work gets done in my app.
Mm-hmm. It's the way how you make applications more robust against failures in pieces, and how you decouple parts of an application from each other so that things don't need to go and happen at the same time, as I'll explain. And also, if you need to effectively balance load within your application or between parts of the application, then using queues is a great way to deal with that. And if you need to deal with tons of events and you need to kind of catch the rain, then that's infrastructure that can go and help you.
For sure. So why don't we kind of dive into it? I know you had some slides you wanted to share, so I'm going to go ahead and share your screen right now.
Yeah.
And let's kind of get into it.
Okay, great. So I brought some slides, but I also, and just for you, Cecil, I also brought some demos, because
I love that.
In recent years, I have been a little greedy with demos. I have done very few. But today, just for you, because you said I should go and bring demos, I brought demos. So
I love that. And, I love demos, and I'm sure everyone that's watching, they're really going to appreciate some of these demos too. Great.
So take a moment for everybody to go and subscribe to my Twitter. Thank you very much. And let's go. What I'll talk about is, and what I'll show is a set of services that we have, ServiceBus, EventHubs, EventGrid, and Relay, which are really making up a family of services. What's important to understand is that they don't compete with each other. I see very often that there's folks talking about, using EventHubs or Kafka as the only message bus, and then versus ServiceBus. That's not how those things are designed or are meant to be. They're really a family that implement different patterns, and they need to be different because the patterns are so different that they justify having a different service. So this is effectively the summary slide of what I'm gonna explain to you in the next 50 minutes. We have EventGrid. EventGrid is an infrastructure that is a push broker. You push events in, and then events flow out in a push fashion, which means we can go and send data to webhooks. We can send data to queues. We can send data to event hubs. EventGrid is solving the problem of calling webhooks, invoking webhooks without having to deal with the webhooks probably not responding, the probably being down, they're being busy, etc. So it creates decoupling as an infrastructure. ServiceBus is a classic queue broker. I'll talk about the queue pattern in more detail, and you push data in, you push messages in, and you pull messages out, and those messages can then be individually handled and individually settled. So we'll get to that. EventHubs is also push-pull, but the pulling is different because the client determines where in the retained message log it wants to go and pull data. And also EventHubs is partitioned, which means it takes lots of data and splits it up into several lanes. And think of that as like a highway, right? If you need more capacity on a highway, if you need to have higher flow rates, you put more lanes on the highway. And that's exactly what EventHub does. And then Relay is another service which kind of complements those two. The first three services are really datagram services that deal with discrete elements of data that they move around. And Relay is a different service that's dealing with connectivity, but it composes with the other services, and it's more used for synchronous invocations, but I'll get there too in terms of explaining what that is all about.
Okay, so then if I'm supposed to think about it, particularly in regards to the messaging services, so EventGrid is like, hey, I want to broadcast notifications.
Yeah.
Like, stuff is happening, and I want people, or I want things to know that stuff is happening.
That's right.
And then with ServiceBus, I'm guessing I need work that I have, work needs to be done, and I'm going to send it to a queue. And then whenever the thing on the other side is ready for that work, I can come get it. Perfect. And then now with Event Hubs, I have, like you said, like a long piece of tape or like a line of things. And then now I could kind of go back and forth in time and, inspect things, but not just one, but I can inspect a collection of messages and kind of do work in batches. Would that be correct?
That's right. Yeah. And so You would use, for instance, Stream Analytics to go and run over a stream, and you can go and inspect events or a particular value that's contained in an event over a stretch of time, to calculate an average, to calculate all kinds of aggregations, or to later compact this. So that's what Event Hubs is for, is effectively looking at events as streams, right? As a time series. It's organized across the time axis, while ServiceBus has discrete elements, and those discrete elements are things that you act on. Let's start with ServiceBus as the first service that we go a little deeper on, and what's in ServiceBus. ServiceBus has queues and topics as their as top organizational elements, as entities, as we call them. A queue is a log of messages where you are sending messages in, and you are effectively appending them at the tail, and then you can go and pull the top message out. And what that gives you is a way to do load balancing and to level effectively the load of an application. We're going to have 2 slides about this in a moment. What it also gives you transactional behavior. So it's possible for you to take a message from one queue and then do some work, post the result of that work to another queue, and have the deletion of the input message and the posting of the output message to happen in an atomic transaction, which means you can hide the results from any other consumer until those two things work, and that approximates the classic transaction model that we can't have in the cloud, but it creates a way to go and create consistency inside of a system that kind of approximates the old model of two-phase commit transactions that people are familiar with from smaller systems that they run on premises. So it's your transaction anchor in the cloud, if you will. And then topics are a way to go and post one message in, and then you can have subscriptions on that topic. And a subscription means that you can go and have a copy of the message for yourself in your own queue. On one topic, you can have up to 2,000 subscriptions, which means you can route to 2,000 different destinations. Commonly, that's not done. Usually, you have a few dozen of these subscriptions for parts of the application, but you can effectively go and create routes with those topics. Let's drill one further down into queues, where you have the key pattern, and that's the difference from. So lots of people have their first experience these days with messaging is when they're using Kafka, because that is a fairly popular OSS event stream broker. And one of the things that Kafka doesn't do is competing consumers. And that's something that classic queue brokers do. And that's a key difference. And that's also one of the motivations for why, just using one thing is not the best idea, because there are patterns that one of those infrastructures does and the other one of those infrastructure does not do. So using a combinations of those makes a lot of sense. So what does competing consumer mean? The queue manages which message is currently being handed out to consumers. So the process that pulls messages walks up to the queue and says, I want to have a message. And another process also walks up to the queue and wants to have a message. So they compete for messages. The broker will now hand out, kind of in order of arrival, will hand out messages to those various different consumers. When those messages are assigned, those messages are owned exclusively by that business process, and the business process can now go and on its own time work on that message. The message is never going to be seen by anybody else. When that business process is done with that, it will complete the message, which removes the message from the queue. It can never be seen again. If the business process crashes, eventually the message will go and show up again in the queue because it hasn't been handled. Effectively, the lock on it expires. And then there's another way, like if you see that the message is faulty and you can't process it and nobody else could possibly handle it, you can put it into a dead letter queue, which is a queue that kind of exists on the side of every queue, where you can go and put it for special processing. But the key here is that any number of consumers can show up and they can go and compete for messages, and every message is handled singly, which is different from event brokers where you're grabbing a batch of messages and then you're effectively advancing the cursor for the entire batch of messages, but you can't handle messages individually. And also, it's not the broker who decides which messages to read. In an event broker, it's the client which decides it reads. And we're going to see that in Event Hubs. So in addition to competing consumers, what you also get is load leveling. So meaning because the business process pulls, right, it gets the message from the queue. If there's a lot of traffic that's coming into the queue, the business process potentially cannot speed up. It might be an older application that has been built for interactive use, and there's many of these. So let's say this can do 10 transactions per second, but you're getting like 50, 70, 100 transactions per second in spikes. The numbers don't play a role what they really are. So if here there are 70 and the capacity here is 10, well, then this thing would probably be overwhelmed. So if you put things into a queue, this will never do more than 10 because it will go and pull and do the work, and pull and do the work, and pull and do the work, and the extras are going to queue up here. And then you're going to go and play some entertainment until your work is done. So that's what load leveling does. It allows the business process to work at its own pace, and then you can observe the queue length and add more business processes if that's possible. And that's something that also is done by Azure Functions. Azure Functions, for instance, observes the queue length and then scales up. And Kada is a scaler for Kubernetes that also does that. And then, of course, the business process might not always be online, right? Systems go up and down, and especially if you have legacy systems, they might not be available. And the queue is a great way to store information that can be handled later, and then you can go and shut the system down. You can bring the system back up, but the system might fail, but the rest remains robust. One little anecdote on this one, Cecil.
Yeah.
When Halo 4 started, the game, like when that launched, there's a little episode on Channel 9 from back in the day.
Yeah. I should look
that was actually that was fronted by queues in a very similar way, where you had the game was feeding information through queues at that time. Today it's using event hubs. On launch day, for several hours, the Halo 4 backends were down. And what helped was there were queues, no data was lost, and nobody knew that the backend was down. And so that's a advantage of having effectively a queue in the middle. So
it definitely makes your environment a lot more robust too, right? Robust to failure, and also too, it allows you to have a certain level of transparency as you're building your apps, because now like my producers and consumers don't need to know about each other. Right?
Correct.
Like I don't know how many they are or where they live or anything like that. Like I could just send messages and walk away, right? And I could just receive messages, and I don't really need to know about anything other than like that intermediary where those messages are living.
That's right. So let's take a look at some things here. We'll see this later.
Oh, is it demo time?
It's demo time.
Nice.
So I have spared no effort and set this up with Power Toys. Can I go and make some advertise Power Toys, please?
Yeah, let's advertise Power Toys. So what is Power Toys?
Awesome. Power Toys is for Windows that you can get, and you can go and make these Windows snaps. So you make these little layouts, and I'm using desktops.
Yeah.
So I make these desktops and those layouts, and I can go and snap those windows to that, and it's really cool. Okay.
Oh, nice. So then you can have different sections of your screen for different things and kind of just put them into place.
Yep. So you basically just make those sections, and then you can go and snap the windows to them. It's astonishing. It's really good. And it does all kinds of great tricks, but these fancy zones are amazing for demos. So what we're going to do is we're going to go and send some messages. And we're going to go and send some. So I have QA here. QA had 40,000 messages. Those messages will be gone. It's empty now. And we're going to go and send 20,000 messages without batching into QA. let's see how long that takes. Doop, doop, doop. And that took, so we did just 4,400 messages a second. Well, -1 is probably a little excessive, but the average here was 700 milliseconds in settling. The reason why that was, so that seems a little slow. Let's go and do something else. So now I sent 2,900 messages per second, but it only did 29 cents. Why is that so? Because I used some batching here. So all of those messages in those demos are a 1K that I'm sending. So you'll notice that there are some difference here. Now I'm actually having sent latencies, 20 milliseconds, 40 milliseconds, 70 milliseconds. The max is kind of 120, which is pretty good send times. For those 100 kilobyte messages, really. But there's a difference here in these send times and these send times. And so now what is the difference between them? And then let me just show you one last thing. Actually, let me do this down here so we actually have the comparison in the picture. I'm just going to go and send them singly, but I'm not going to send as many. I'm going to send like 1,000, 100. So, all right. So let's go and take a look at some code here.
Right.
All right. So here's what I did was sending. So I have this little app that I wrote. All the code is shared in that repo. I'm using here this little commands tool, McMaster, the McMaster command line utils, which are great to build these kind of little apps. So let's see what we're doing. I'm using the brand new ServiceBus client that is part of the Azure SDK now. One thing that's beautiful about it, if you have used ServiceBus before, is that connection strings are gone if you are using integrated security with ServiceBus and Active Directory. So the way how that works is when you go and create a queue or you are in a namespace, let's go and find the, so here's my namespace. In the access control page, let me just go and make that a little bigger so you can see. This is only at 80%. Okay, let's make it 110, 20, so you can actually see. All right, so here's here's the access control. Here's the access control panel. And in the access control panel, you need to go and grant yourself permissions to send. Even if you own the namespace, you only own the control plane. The data plane has different rights. So you can be a ServiceBus data sender, receiver, or owner. I'm the owner, right? And now I get to pick myself here. So Clemens V. I already have those rights, so I'm not going to go and click the button. But that's how you grant yourself effectively access to the data plane. And as soon as you have access to the data plane and you are Active Directory connected to from your machine, then it's like using integrated
security with SQL or something. It just works.
Yeah, exactly. It's like it's all magic. You don't pass any credentials. Your security context just flows over into ServiceBus, which is quite awesome. So that's kind of what just happened here. So I only give the namespace name and the entity name. So that's really equivalent to what I just did here in my command line. And then I sent. Now, this -A option that I had was async completion. So this is this code. Okay. So what I'm doing is I'm creating a ServiceBus message, and now I'm doing this. I'm sending a message, and then I'm taking the task that I'm getting out. This is a sent message async, and I'm adding that task to a list. And then I'm awaiting at the end of the send, I'm awaiting the list. Okay. Compare that with the other thing that I did, which is slower. which I only did for 100 messages. I should have done that for much longer. This is incredibly slower because what happens, you send the message and then you wait for the acknowledgement. Let's think about that. When you send a message and you await the call, then the message goes to the broker acknowledges and then comes back, and then that comes back to your await. Those things are slow, and you will only see like 100 messages per second using that path. With this, you can get 1,000 messages a second or 5,000 messages per second, as we've seen. Because why? One send doesn't block the next send, So what happens is that all the messages go into the channel effectively in one swoop, and then all the acknowledgements come back. And since AMQP is an asynchronous protocol, you get far more throughput using that trick.
Nice.
Okay. So that's one little thing. And then on the side, I could also show you the new API. So ServiceBus client, you create a sender, and then you say send message async, as you would expect. And that's kind of how you send into ServiceBus. That is quite simple. So
before you go on, there's a few folks that are in the chat asking about the ServiceBus SDK.
Yeah.
If you had a previous investment in whatever the previous version was, and now you want to move to this newer version of the SDK, is there a tremendous amount of code that you have to rewrite, or is it pretty easy?
So yeah, the new SDK is quite a bit different there, but there's a migration guide that is in the new SDK, which tells you how to do this. Now, I have a little gift that I brought. Let me go and see I find it, and that is in here. So if you like the new authentication thing, which is it's super magic, right? So if you want to use the integrated security, but you are using the old library, there's a thing that I did. And the thing that I did is in console consumer, in the receiver, in the program, in here is somewhere a token credential provider. Let me just go and zoom that. Okay. So this thing is a little wrapper that's turning our old token provider, so that's turning the new token thing into our old token thing.
Oh, nice.
Yes. So that you can go and just use a normal ServiceBus connection. And then you can set the token provider for that ServiceBus connection to this new token provider using the magic new fantastic default Azure credential, which picks up the credentials from everywhere and just logs you in. And so that will make the old APIs work with the new security stuff, and that's a very clean way to basically just stick with your existing investments, but still upgrade to this new path of being completely integrated with the rest of the Azure SDK.
Nice.
I literally just made that up for this demo. So Cecil, thank you for making me do this.
I feel like you're bringing us so many gifts, man. I appreciate it.
Yeah, well, that's if you invite me to do a talk, then we'll bring gifts.
That is awesome.
So let me go so we're still here in this sample. Got to make it smaller again. So we're in this queue, and I send how many messages did we send? We sent a few thousand messages into this queue, and
it was like almost 4,000 or something like that.
Yeah, and we will find, oh my God, the queue is empty. What happened? Well, what I did is I used a feature that's very handy for these scenarios and for many others. I construct the message kind of down here, and I'm setting the time to live to 2 minutes. So those messages we've been talking, so those messages have expired and they have now vanished, and so they're no longer there. So let's go and send another 20,000 messages in here. Well, let's send 40,000 messages in here.
And then also for people that are watching, like so because you set that time to live, those messages are disappearing. But for folks, like if you just send messages and not set the property, your messages won't disappear. You have to explicitly set it for them to, have that lifetime.
They live for however long you define. There is no set expiration for messages in ServiceBus. So So we suggest a limit, and there's a default limit on a queue that we set, and it's like 14 days or so, but you can always override it. So if you need a message to live in a broker for a year, you can.
Okay. Someone in the chat is asking, do they just disappear or do they go to the dead letter queue?
You can choose whether they do that. So you can choose that expired messages go into the dead letter queue, or you can just go and make them vanish. There's a setting for that.
Got it. Okay.
So and this is the setting right here, is disabled a message expiration dead lettering. So you can go and I can go and turn that on here right here, right? But I don't want that, because the whole point why I'm expiring in this demo is that I want to have them gone. So you can turn that on here. Okay, so we have sent some messages now. I've been talking again. Let's see whether the messages are still there. They are. Let's go and receive some. And now I'm receiving messages in this window, and they're all different. I'm receiving messages in this window.
I like that little animation you got going on in that window.
Every message has its own color.
Nice.
It's actually associated. It's based on the hash of the session ID, which we're going to get to in a second.
Okay.
So all of those are competing for the messages, and they already are through the whatever 20,000 messages that I sent. So let's go and send, or 40,000 messages that I sent. See, that's empty now. And we're going to go and send another 20,000. And so they're now picking them up again. And competing consumer means, in this case, that all those messages are now they're all hanging there and all waiting. And they're consuming them effectively as they get assigned by the broker. And of course, this little statistics line that I have here is only printing every 10 seconds. So the numbers, the receiver numbers are actually a little bit off. So that is competing consumer, and that is kind of showing a few tricks of how you can go and send messages. From a receive perspective, we haven't looked at the receiver just yet. There's multiple ways of doing consumption, and you can let me just go to the right place. So here's a receive loop. So you make a ServiceBus client, same thing as we did before, and then you create a receiver. You set your receive mode, which is receive and delete. Is you don't have to acknowledge the messages. The messages are being taken, deleted in the broker, and then given to you, which means that if you fail, the message is going to be gone. The default mode is that you use peak lock, which means the message is being locked, given to you, and then you have to go and complete it.
Right.
That is this completion mode here. Okay. So here I receive a message, and if I have received a message, the message will be null if the call was canceled. Then I will go and set the color based on the session ID or the subject. And then I will go and complete the message if I have to, effectively, and otherwise I just increase the count. And if there's anything that happens with that message, I will go and abandon it, which means that the message is going to be returned back to the broker and can be served up to someone else. So building those message loops in the right way, because you need to go into the try and the catch and call the right thing in the right place, and it can be really complicated. This is an advanced scenario. What you should do generally is you should use something else. You should use either this processor model. So the way how that works is you, again, create a client here, and then you go and create these, you set the processor options. This is where you can effectively define how the processor shall behave. And then you set the effectively the callback that's being called for every message that has been received, and then you start the processor. And the processor will go and talk to the queue for you. It will go and pull messages out and effectively turn it into a reactive model where you are being pushed messages that you're getting. Autocomplete means that if you don't throw, right, the messages are being completed for you. If you throw, they're being abandoned for you. Max concurrent calls means that we're fetching more messages, and we're actually spawning worker threads on top of this callback for you. So we create parallelism. That's something that's really difficult for you to do yourself. So we're doing this. Prefetch is something that the client builds in. We're actually getting more messages ahead of time before you process them. And then auto renewal means that if you process longer than the message lock than the message lock time, we will automatically make sure that the lock doesn't expire on you while you process. So all of that is done by the processor. That's the thing you should go and generally use. Azure Functions is the other way of using the queue, and that's also using this very similar underlying model. So Azure Functions is the easiest way to consume the queue, and we're going to go and take a look later at how Azure Functions is using event hubs.
Sure. So Clemens, I got a quick question too. I wanted to make sure we get this one answered. So a few folks have been in the chat asking about being able to run messaging and service bus and stuff offline, like outside of Azure. So someone mentioned something about having an offline emulator. Is that something that is there something that we could say about that, or do we have something else we tell people to use, or
yeah, so I can say something about that. That is, I would like to. The problem is that we need to have a way to make that sustainable, and ultimately that's a priority decision that is complicated, and it's not my decision. I mean, that's just what it is.
Yeah, it's not your choice to make. Someone else has to okay that.
Yeah. And so, what is the alternative? We have done heavy investments into AMQP. Mm-hmm. We've also done heavy investments into JMS. So, and JMS is not an objective here because we're doing .NET. But let's talk about AMQP.
Yeah.
So if you need to have an on-premises broker, if you want to go and talk to an on-premises broker and you want to hook up something to the cloud, then RabbitMQ with the AMQP1 plugin and ActiveMQ speaking AMQP are brokers that speak effectively the same language on the wire as ServiceBus does. Our SDK doesn't speak to those brokers just yet, and that's something that I would like to see. However, the AMQP stacks, which means kind of pure AMQP clients, they can talk to all those brokers. So I know that that's not what people want to hear in terms of emulator, because it's not. But in terms of having a integration between on-premises and in the cloud, where you can go and run a RabbitMQ and then hook that up easily with ServiceBus, that's a solved problem, and that's in our documentation. You can today use the RabbitMQ shovel and just hook that up to ServiceBus, and we also have that in our documentation. So you can build hybrid systems, but a direct emulator is something that I would like, and our team would certainly like, but the problem is that ultimately we need to make that a sustainable effort. And because those emulators are ultimately they're real brokers, and they need to have support, and building a little thing is an enormous investment, and that's just what it is.
Got it. Yeah, right. And again, in the chat, folks are just saying, hey, it's not even so much about. And again, I'm just passing on the message. It's not so much about having something running on premise, but it's more so just having something for development time. So I'm guessing if there was a thing that could be built into VS Code or Visual Studio or something.
I understand and I hear you, but it's ultimately you will want to have full fidelity. We had ServiceBus for Windows Server from 2012 until 2018, which was the actual broker, and that was a free download. It turns out that that had significant feature differences ultimately because of the sustainability issue, and that then became a giant issue because it was not at parity. And it won't be at parity if we just make a little thing that just runs in Visual Studio. So that then becomes another source of ire. So it's a
hard problem to solve.
It's a hard problem, and I'm genuinely sorry about it.
Got it.
All right. So there's also so we're now in the next demo, even though it doesn't look like it. I have now the session mode. So you know that you've seen that I've sent messages, 40,000 again in both sides. Well, let's see what this does. So the session mode in ServiceBus allows you to multiplex data through the queue. So what you see with the colors here is that I've been sending data into the sessionful queue, and now I'm effectively retrieving based on sessions. What you can do with ServiceBus, and that's a fairly unique thing, is you can effectively use it as a multiplexer for as many concurrent sessions as you like. The way how the sessions work, and let me just go and show you that in the code here, where's the sender? Hang on. Is that I'm setting the session ID here, and I'm setting it to 1 of 16 values, which means 1 of 16 colors ultimately in the demo, right? So the session receiver, which is here, and that's another mode. So these are the session processor options. That will go and grab a so-called session and then process the message on top of this. Since that's a little obscure, let me go to the SDK, to the explicit call, and show you how this works. And the explicit call is right here. So you create a client, and then you call accept next session. What accept next session does is it grabs effectively the next message that's available, and then locks that message and locks all the following messages with the same session ID to that one receiver. So if you have a sequence of messages, that entire sequence of messages with that session ID is now not going to be given to any of the competing consumers. You own it. You own that message and all the messages that are with that session ID now in the future, even the ones that have not been sent to the queue yet. You have a lock on that session ID. And now you can go and oh, you're muted, Cecil.
You'd think I'd get this muting thing right by now. So I was saying, so this could be a way that you could create like a workflow, right? And so I have a set of steps that are dependent on the previous or the next one, right? And so I need them to be processed by the same worker, right?
Exactly.
And so now I could kind of do that with something like sessions.
Yes, and even better, in the session, effectively, right? The session is here represented by the receiver. Now you've received the session, you can go and call a method that's called on the receiver, is called receiver at session state. And you can also set session state. So we have a feature inside of ServiceBus where you can go and grab a session, you can get the state that's associated with it, process messages, you record effectively where you are in the processing of the session, put that back into ServiceBus, and then put the session away, and someone else can go and pick up the session later and then keep going with that. And that's how, for instance, SharePoint workflows work. They are using ServiceBus session state facility effectively to go and scale the workflows out.
Nice. So then I can imagine like something bad happened, right? And so in my exception handler, my unhandled exception handler, I could save the session, and then whenever a new worker pops up, it could say, hey, give me the unfinished session and I'll finish it for you.
Correct.
Got it. So quick question again, coming in from chat, and someone is asking, is there a limitation to the number of sessions that you can have?
No, you can literally have millions of sessions. There's the only limit for sessions is that if you store session state, the accumulated session state cannot exceed the size of the queue, which means 80 gigabytes, which is plenty. But there's no limit. Like you can do unlimited multiplexing, and as you can see, you can also pinpoint. You can ask for a specific session and just pull on that.
Got it.
So it's a super powerful feature to do multiplexing, demultiplexing through queues. And with the session state feature, the session state feature is completely unique to ServiceBus. No other broker has that.
Got it.
And it's specifically built for the workflow scenarios. All right, we are done with the ServiceBus demos. Oh no, we are not. Hang on. The other ones will be a little short, I'm guessing. So here we are now in
And one more question just came in about sessions.
Yeah.
So this one's coming in from YouTube, and the person is asking, does the session expire once all the messages for that session are processed?
No, sessions live forever, and there's no start and no end. All the sessions that can exist already, and and the so
they're like omnipresent. They're just there.
Exactly. They all already exist. They are unbounded by design. So you can choose to bound them by having a message that's an end message, and then you stop paying attention. But as long as there's no limit to them.
Got it.
So what I have here is a topic. I just want to show you a topic too. Setting messages into a topic. That's the same story that I had. This I'm sending this without batching, so it's a little slow now. So you see, there's messages showing up, and there's messages showing up in S2. So all the messages are flowing in. Let's see, where are we? We sent 1,001 messages, right? And in S1, there's nothing in S1, but you've seen kind of in the middle that there was like one message was sitting there. So that's a little weird. So anyway, so a topic, as I said, one in, and now you have per subscription, you kind of have your own queue. It's a little odd that there is no queue here. Let's go and take a look at that, or no data here. What we did here is we had a forwarder. So this subscription doesn't keep its messages, it actually forwards them onto a queue. So I can go and find in this namespace queue foo1. There we go. And I would expect that to have 1,001 messages, and it does. So you can go and create forwarding topologies. You can go and create routes. What we didn't look at are the SQL queries that you can go and do against the messages to kind of decide whether a message becomes eligible for a subscription, etc. So you can go and create full routing graphs inside of that. Okay, so we spend a lot of time on ServiceBus now. Let's go back to the other services and event hubs. Now I have to go and speed up, given that we only have 12 minutes nominally.
But we can go over a little bit, so that's fine.
Okay, great. So event hubs is an IoT hub to a degree, right? The IoT hub sits on top of event hubs and has certainly the same tail end, the same receiving end as event hubs. Is our super high scale ingestion broker. Our biggest event hub that we host for an external customer has over 2 gigabytes per second of capacity. We do well over 3 trillion events per day. The count goes up very quickly, so maybe we might be at 4 now, or over 4, several petabytes that go through the system. And event hubs exist in all data centers. It's certainly the service that has the most load, and that's because it's used for everything that has giant torrents of events. The characteristics are that it separates event streams into partitions. I said highway lanes, right? So if you need to have more capacity for a highway, you have more lanes. And so a partition, think of a partition as a highway lane. One partition has a cap in terms of throughput that it can make, because ultimately it's a log that needs to be shared, needs to be put on disk. And to overcome that limit, you simply split the stream up. And that's what you do with partitions. And the way how we help you with that is that you go and take the data that needs to be in sequence, and you label it with a partition key, and then we assign that to one of those partitions. The difference between what we have here in Event Hubs and what exists in ServiceBus is that the clients are choosing what they want to read. So either they read at the start of the log, which means the oldest messages first, or at the tail of the log, the current messages, or any point between them. So you can go and scroll by time and pick a point in time from which you want to start reading messages. We retain messages, raw event data from 1 to 90 days. We don't retain that forever. There's no way to go and store it forever, because we believe that data in event stores is no longer useful when the primary index is no longer the time axis. And I'm going to talk about that in a second. So that's the general pattern. Let's talk about events for a second, and why those event brokers even exist. And here I'm just taking the example of a securities market and the market data. When you have market data in real time within the first minute of its existence, that's when the data is most valuable, and that's why when the markets make millions in selling that data, right? Bloomberg, for instance, has made his entire fortune based on selling that data in a very timely fashion. Once the data is older, a few minutes old, the value drops dramatically until it's basically worth nothing after 24 hours. So freshness is kind of the key element of why those events are so valuable. And because the freshness counts, you need to have an infrastructure that catches them and makes them available as quickly as possible without doing any pre-processing. So the motivation for these infrastructures, for something like Event Hubs, is to just get the events collected in order and then make them available for processing in parallel. And that's what I call catching rain. So those occurrences, the events happen, you want to go and capture them, you want to go and put them in order, you want to put them on disk, you want to make them available for consumption. There might be some optional layer in the middle where you go and do some transformations on them or adjustments or filtering on them. You might want to do that with Stream Analytics or with Azure Functions, for instance. And then you make them available for, but again, that's optional. And then typically they will be consumed by multiple sources in parallel. One for parallelization, one for visualization, one for analytics, another one for analytics in a different shape, and one possibly for archiving or batching for then later for batch consumption. And all of those things happen in parallel because freshness matters, right? The more events age, the less they become interesting for many scenarios. The time axis matters, and while you are in the real time layer, kind of at the top of this, on top of the dotted line here, you're taking this telemetry data which comes from vehicles, right? This might be the vehicle manufacturer, this might be a fleet manager, this might be some logistics company. Information comes from vehicles attached to Event Hub, and now the data goes through Stream Analytics, goes all the way through to Power BI because you want to have a dashboard, or you want to have a map where you can see where the cars drive. And once the car has driven, well then, the prior event is no longer important, but you want to have the visualization right here. If you want to go and look back at history, like you want to know why this car broke down, and you want to understand then what the oil pressure was on this day from 4 until 6 during this hour when the car was about to break down, that's where the time axis, this primary index of time, is no longer useful, which means in parallel to doing this processing of the real-time events, you will want to go and play the data into a store where it can be properly indexed, so you can ask for different pivots than just the time axis. So Event Hubs, Kafka, and all the other kinds of event engines are really useful as long as your primary index for looking up data is the time axis. As soon as the primary index becomes something else, then you're better served with a database, which means you should go and funnel the data then into a database. Let's go and take a look at that.
Demo time again.
Huh?
Said it's demo time again.
Demo time again. Let's go and see where I'm at with my. Okay, this is the one. That is the one. Are you still running? All right, good. So where are we? There should be a clean one. That's the clean one. So this is our Event Hub test. Again, what we're doing here, we're sending some 100,000 events. I should take the weight away. And, right. So we're just rushing 100,000 events into Event Hubs. And we have a receiver here, 3 receivers. Let's go and start one of those receivers first. This is an Event Hub which has 4 partitions. And we're using the greedy method, and what you see is that this reader reads from all 4 partitions at once. Now we're starting a second receiver. And the second receiver, just see, it stole 2 partitions from this receiver. If I start another one, oops, this will eventually go and steal if there's enough messages left. Yep. So this just stole another partition. So what happens here is that this is using the EventHubs SDK, and the EventHubs SDK, the processor, that will go and effectively coordinate which of these processes gets to own which partition, so that you can go and effectively process all of those lanes in parallel. And if you have 32 partitions and you start whatever 20 receivers, it will go and balance that out automatically. If I give up partitions, so I do this, so I stop those processes, then eventually after some time, I've set a threshold that's a little long. Actually, this now ended. That was unclever. I just stopped it at the time where the events were gone. So this is already acquired now the second partition, and eventually it's going to go and acquire the other two partitions as well. So what we make sure is that one receiver gets one partition. So you push all the events into arbitrary order, and then we make sure that the events that belong to one partition are being pulled in that exact order that you submitted them. And we're dealing with all the balancing for you. This is using the .NET SDK for, so this is the sender. And you'll see that this is very similar to, this is the producer client here, very similar to the ServiceBus SDK with a little difference because we're creating these event objects and not messages. They have fewer properties on them. And then the receive side of this, I think I have that in another window. Hang on. I think I had that here. The receive of this is, you have this event processor, you create a blob container. That's where these checkpoints are stored. So you create a blob container client, and then you pass that storage client to the event processor client, and the processor client will then has an event handler. So the model is very similar to what we had in the in the other example.
Got it.
So it's all fairly simple if you want to do this. And then just to show you without running it, so here's how you can use event hubs from Azure Functions. You have an event hub trigger, and you tell it which event hub to read from, then which consumer group. So every application effectively gets its own group, because it also needs to go and scale out. The thing that we just did with the multiple receivers would typically be one app that gets scaled out. And so Azure Functions will make sure that it gets enough instances to go and deal with the current load. What we do here is we do an input from event hub and an output into Cosmos DB. So the parameters are that you have effectively a event hub batch input, so it acquires a batch of event data, and then we have this async collector, which is the output, which are effectively objects which go into Cosmos DB. So what I'm doing here is effectively I'm reading all the events, and now I'm effectively taking the partition key as the ID for the record, and then putting the data in here. The effect is that I'm inserting into Cosmos DB every single event, but since ID is the primary index, I'm doing upserts, which means I'm only getting the last value of every partition recorded in Cosmos DB, and now I'm actually having an index store. There's a mechanism that exists in Kafka, which is called log compaction, which effectively throws away all the records except the last one with a particular partition key. So it's similar to this. Yeah. But to get at the data, you still have to read the entire log, which means the lookup performance is of course atrocious.
Right.
And here you have a proper database, and you just walk up to the record and just get it. So we prefer this model of projection rather than compaction. And compaction is first slow, and second also destroys the source data. We're liking this model, and it also allows you to do the conversions, and doing that is super, super easy here with Azure Functions. And that's also a way how you can go and do these triggers. All right.
Cool. All right, and now a couple more questions coming in. So I want to make sure that we get to these. One person's asking, does iAsync collector guarantee order while using sessions? And I'm guessing he's talking about the iAsync collector that you were showing in Functions.
Yes, that does.
Okay.
So that was a question that I had too. There is some trickery in some guidance that we have for replicating event hubs, which I'll show at the end, where you can go and find a little bit more of this. There's an assurance that you're getting the events are being inserted in order. The only thing is the events that you're getting, if you have a mix of events, so you're getting data from multiple partitions, that might end up in the batch that you're getting into your Azure functions. There's some chance for order. Read the documentation.
Sure.
So typically not a cause for concern, and with the new SDK, with the new versions, that's not going to be a concern at all.
All right.
All right. So that was Event Hubs and Service Bus, and we're now over time. But I'm still going to go and do the last two. Event Grid is quick, Relay quicker. Event Grid, as I said, push. What does Event Grid solve for you? It solves for you that if you are trying to call a webhook and the webhook is down, and you are doing this in your own application, what are you going to do? Are you just not going to call it? Are you going to sit there and wait for 5 minutes? So Event Grid takes your event and then takes 24 hours to go and try to reach that endpoint. And if the endpoint says too busy, it'll wait. If it throws an error, it'll go and back off. So it will go and do all the patient work to make sure that the event eventually gets delivered. If it doesn't, you can dead letter it, which means you're gonna go and find out. Oops, what did I do? What did I do now? Okay. Event Grid can also route into Service Bus and into Event Hubs, and it is a PubSub engine, which means that you can also do filtering on the events that you put in there. The way how Event Grid works is the way how you can use it is two ways. First, you can use system topics, which I'm going to show you in a second, or you can go and use custom topics. And custom topics are effectively like Service Bus topics. You can go and create a topic and then send events through it, and then subscribe on them. I'll go and show you a system topic as an example. Okay, so. Which of these fantastic windows is it? Oh, that's obviously not it. I think this is it. Okay. So we are here in the storage account. I'll go and make this a little bigger again for you guys. Okay. Maybe that's a little big. Okay, so
there you go. That looks good.
In every storage account, you'll find this Events tab, and the Events tab is for creating event subscriptions. So what you can do is you can go and subscribe to things changing in your blob account. So I can go and call this foo or whatever. I'm not going to go and save it, and then you can go and pick types of events, things that happen. So directory was created, blob deleted, etc. And then you can decide what you want to go to do, what you want to call, and that's like an Azure function. And if this is an Azure function, it will give you kind of a little selection here, and then it will go and propose a function. And you confirm the selection, and it goes and hooks these things up. That assumes that I have already deployed one of those functions, and which I have already done. So this the subscription actually already exists in the form of, let's go back here, in the form of this. There's a list here. There's the blob mover, which I have deployed. And whenever there's something happening, whenever there's something being called, that blob mover gets called. And here in this application, I have the log stream, and kind of whenever there's something being posted in here, you see that there's an event fired. And the reason is that I have this log information here. So that's the Azure function. The Azure function is effectively getting a grid event, which is then getting all this information, like which is the file that has been created, and you basically get a link to it, and when did that happen, etc. So if you wanted to go and build an application that is reacting on JPEGs being updated, uploaded into a blob account, and you want to go and resize them or create thumbnails, etc., this is the way you do this, right? You simply write an Azure function, hook that up to an Event Grid endpoint, and then you're going to be called. And of course, as the system does that through system topics, you can also do that through your own custom topics or our partner topics. So that's effectively what Event Grid is. And with Event Grid, I could also go and subscribe into a queue, and now I can go and get storage events into ServiceBus or into Event Hubs as well. That's also possible to go and do that. Okay, so that was Event Grid. Where's my mouse? Oh, I think my mouse is currently stuck. Hang on, let me just go and reboot my mouse.
Sure, no worries.
It's the Bluetooth thing.
Yeah, and I'm just looking through here. Someone had a question about webhooks, and now I can't find it. So I'm sorry. If I find it, I'll ask you. But you go ahead. So
last thing I'll talk about is the Relay. The Relay is the oldest service that exists in Azure. The first preview of that was on May 31st, 2006. How is that possible? Because it started as live labs, and it was one of the first public experiments that we did of this sort, and it was built to have. I mean, this was pre-cloud, so everybody was behind firewalls. How do you get people to talk across their firewalls? And that's the Relay. And so the Relay is built for exposing microservices from behind firewalls, or just to reach anything and everything. And scenarios are lots. You want to have synchronous access without VPNs. You want to go and talk to the database. You want to go and talk to an RPC service that sits by the firewall. You want to go and talk to an RDP. But you don't want to go and set up a VPN. Maybe you don't get control over VPN. Visual Studio Live Share is using this. So the way how Visual Studio Live Share, how two people find each other using Live Share, is using the Relay. That is the scenario. Right? There's a SaaS app that is Visual Studio, and that is, you have on-premise 10 assets, which are your Visual Studio instances, and they get connected together using this. We have tons of scenarios where vending machines are being connected, point of sale systems, tax offices, medical offices, ticket sales, venues, et cetera, all through the Relay, because the Relay kind of gives you a reverse WebSocket, which goes across firewalls, so that you can call into an on-premises system while the connection is actually being originated from them.
Nice.
Commerce sites, pizza stores, transportation scenarios. We have tons of them, and all of them are made possible through the Relay. We don't talk much about the Relay, but the Relay is really cool. So
yeah. I didn't know that LiveShare was using it. That's pretty good to know.
So the data gateway is using it, LiveShare is using it, Azure Hybrid Connections is using it. The Relay is the secret sauce in a lot of stuff. And so I don't have a demo, but I can show you some. I can show you the sample, and we should go. I'm going to go and paste you the. Where did I do this? Hang on 1 second. I have this. So, here we go. The Relay is. This is how this works. So I used the .NET HTTP. So this is in the documentation. Get started with Relay Hybrid Connection HTTP request in .NET. Now look at this code, because it's not a lot. You write a little program. I'm going to make this a little bigger. That is effectively creating this hybrid connection listener thing, and hooks up a request handler to it. Opens it, and in the request handler comes an HTTP request, and that's it. So you can now call this thing from the outside using a public address on the Relay, and this call will come to your machine. If you guys go and do this today on your machine from wherever you are, you'll be able to go and call your machine, call this service on your machine from the outside. It's super easy.
Yes.
And you can also create tunnels with it. So we have a tool that's called the Relay Bridge. Never mind that this was not updated for a while, because it just works. Sorry. And so the Relay Bridge is able to tunnel TCP, UDP, Unix sockets, all through this bridge, where you can run an agent like the SSH shell on both sides, and it will go and tunnel that to the Relay. So you can go and effectively do a database connection or an RDP connection all the way through the Relay without changing the clients or the or the servers. You just run the agent on both ends.
Got it.
That's the Azure Relay bridge. All right, and then we're doing bad on time, but I think everybody's still sticking around, so all good. So
this is fine. This is fine. I did want to ask just a couple of questions before we called it a day.
Okay.
I had a question that came in earlier that asked about sending larger messages. And like, any recommendations for that? And I guess that's because ServiceBus and like all the different things have a message limit. So what happens if I want to send a bigger message?
So for ServiceBus, my answer is just wait. Not for long. Just wait.
Okay. Just wait.
So I mean, Ashish is probably going to kill me, but you all promise that you're not going to tell this. So we will. We're in the final rounds of finishing a feature that is called large messages. We have a bunch of customers who are already using this in production, and we are extending the maximum message size for ServiceBus to 100 megabytes. Yes, and the way how this feature is going to surface is that you will be able to actually constrain the maximum message size for yourself for your own application. So you're going to see this show up as a slider or configuration setting that is set to 1 megabyte, which is our current size. And then you'll be suddenly able to extend that slider to 100 megabytes. That's true for ServiceBus Premium only.
Okay, that makes sense.
And for the other services, use the claim check pattern. For Event Hubs and for Event Grid, we are not touching the sizes because it is quite the haul to go and use these large messages. And we've made there's a special architectural change that we made for ServiceBus to make those large messages possible. And we don't think we can reasonably do this in a multi-tenant way for Event Hubs just yet. We might be able to go and expand the message size a bit for Event Hubs in the future after some changes that I'm not going to talk about. But we're not going to hit the limit that we're at with ServiceBus. ServiceBus is going to be the way how you're going to set very large messages. Otherwise, stash the file, because then you're sending files. Stash the file into blobs
storage or something,
and then send a link to it through ServiceBus or through Event Grid, which is for PubSub scenarios. Or anything where you are spreading events to a broader audience, actually the saner approach. Because PubSub means you're now posting that big file once to one place, right? And then you have multiple parties which are all reading from that one place, and ultimately that's more efficient than hauling the entire file around the whole time, with everybody not necessarily being interested in that data.
Right.
Right.
I just shared a document in the chat really quickly about the claim check pattern. So if anyone has not heard about it before or wants to know what it is, go ahead and you can check that link in the chat, both on YouTube and on Twitch, and then you can see how that works. Okay.
So then let's just finally talk about the bigger picture. There's often, like when I have customer conversations, they're often about the broker, just about the brokers, and about this broker that we have versus the competition, this thing, and that kind of misses the picture because the picture is bigger.
Yeah.
Events come from many different sources, and with Logic Apps, for instance, and with which are the same adapters as they are for Power Apps, we have like 380 different adapters where we can go and acquire events from different sources. Right. And then we have a whole suite of edge systems and integrations into industrial IoT, etc., where we can also go and acquire tons of events, which is also part of the story, which we then flow towards our routers into. So serverless shaping is for Azure Functions and also for Stream Analytics. Then we have our event router, which is Event Grid, and then the event log store. All of those things are basically different facets of how you catch those events. What's important for us is that we have an open standard story, right? We're betting on AMQP, MQTT, HTTP, cloud events as a set of standards that we invest in, and our brokers are using these open protocols. we don't believe that the future is about proprietary protocols or project-specific protocols, right? It's nice that every broker like Pulsar or Kafka has their own little RPC protocol, but ultimately they're not interchangeable, right? You can use one client to talk to various brokers. If you're operating on AMQP with you can talk to Event Hubs, you can talk to ServiceBus, you can talk to ActiveMQ, you can talk to RabbitMQ. Interoperability is real in that world. If you want to go and use the interoperable clients, but effectively, if you do Kafka, you can only do Kafka. And we believe that you should not lock yourself in, but you should use these open protocols. And that's what we're also driving that further and have, for instance, for event hubs that is using AMQP, the way how it is doing the consumption side is now effectively in final in the AMQP technical committee for standardization. And then, of course, there's a lot of stuff that happens on the right side of this, which is also covered by services, because that's also part of the important part of the ecosystem. What we see more and more is that these applications that you're building are effectively journeys of events. And either the original event travels or events cause events, cause events, cause events, and that more and more applications are kind of be driven by these kinds of journeys. So there's building blocks, there's database change capture, there's SaaS platform integration, EDI integration, these protocols, kind of the core messaging infrastructure on one side that we've just talked about today. Right. And then there's lots of event-driven kind of infrastructure that sits on the right side in form of databases and data warehouses and archiving capabilities, etc., which are important. And in Azure, we have a lot of those pieces already. So having and they're pretty well integrated. So having a discussion that's just about this broker versus that broker is actually falling short, because you really have to go and think about the whole platform. You need to have a platform that's event-driven and is built on top of events. And Azure is that. And having integrated services, I think, is a plus. And then doing that with an open standards vision and action is ultimately helping customers to build more interoperable applications.
Got it.
And with that, unfortunately, with a little bit more time than we thought we would take, I am at the final slide.
Awesome. But I think everyone really liked everything that you came on and talked about today. So thank you. It was great. And most people no one really left. So I mean that's great. A good sign as well. So kind of like what Clemens said, we are a little bit over time, but hopefully everyone enjoyed everything we spoke about and some of the great stuff that you learned. Again, if you came in a little bit later and you want to know where the demo code and all that type of stuff is, you should take a look at the link that I'm sharing right now. You should see it at the bottom of this window. And this is the GitHub repo that has the samples, the code, and everything that you saw that Clemens was able to demo for us today. Obviously, you have to go and create your own Azure subscription and set things up. But other than that, if you want to look at the code and run it, then that's there and it's available for you.
Yes. Cool.
And other than that, so thank you all for coming. Next week, again, we're still in March, so it's still Microservice March. Next week, we're going to talk about some more patterns. We're going to talk about things like observability and health checks and all kinds of other things that you could start using in your apps. So make sure you come back next week for more on .NET Live. But other than that, thank you all for being here. I really appreciate everyone spending their time, their evening, their afternoon, their morning, wherever you happen to be in the world with us. And we'll see you again sometime soon. So bye, everyone.
Bye.